it kind of reminds me of myself when I was studying robotics. Always like, want to do more, push my robots to do more and get more out of it. And I see this reflection in students. So that's what I really like. Yeah. My name is Shivesh Kumar, and I'm an assistant professor in dynamics and control at the Department of Mechanical Engineering. And I'm teaching a tracks course, which is called Athletic Intelligence in Robotics. So this course is about introducing students to the recent advancements in humanoid robotics and physical AI. The students learn about different dynamics and control methods, also reinforcement learning, and basically whatever new things that are happening in this world.
If you have a humanoid robot, you start to project a lot. What you can do, you think the robot can do as well. But actually those are two different things, and you have to distinguish them too. Things that seem to be natural for us are not necessarily natural for the robot. For example, grasping. Our hand is very high degrees of freedom. We can do a lot of different things with the hand. But the robot hand that we have looks like a human hand. It has 5 fingers, it can move all 5 fingers, but it actually only has 3 degrees of freedom. So the hand that we have cannot do this, for example. And it turns out that this is very difficult to grasp an object if you cannot do this movement.
One of the topics that we've looked into this project is locomanipulation. That's the idea of manipulating an object while you're moving. And this is also related to my PhD topic. Usually you would treat it only mathematically or in simulation. And thanks to the hardware that we have nowadays at the lab, we've also been able to treat it as a practical, real problem.
As a part of this course, they have worked on a task where the humanoid robot is deployed on an industrial task, collecting some work pieces into a box, and then the robot has to carry that box to a machine and load this machine with the work pieces. And then the machine is supposed to finish the grinding task on those work pieces, and then the robot collects the finished workpiece and moves on. I'm quite impressed by the students' ability to implement this kind of demo rather quickly. I mean, just 2 or 3 years ago, this would have taken maybe months of work. And now this field is progressing so fast that we can achieve more and more with humanoid robots in a shorter amount of time.